लाइव हाँ सर वो लाइव स्ट्रीम
Okay, sorry. करें शुरू?
हाँ सर
शुरू करें? Okay. Sorry, what we talked was right, but let us finish it in a proper way. थोड़ा सा मैंने I left something unsaid, so let's do it in a proper way. So what we discussed is the electrons which come from here to here, they continue there, and let's have a good idea. So what I want you to do is, I want you to tell me V out on V in. We are not looking at bias and all here, but that's all right. So we assume Vi is small. So can you calculate for me VO on Vi? So this is normally आपको याद होगा कलेक्टर के साथ एक रजिस्टर होता है when you use the transistor. कलेक्टर के साथ ये VCC इसको कहते हैं. So let's look at that's a very important part of this whole business. जरा वो क्लियर कर दें. So V naught on Vi. Right? तो क्या कर रहा हूँ मैं? हाँ ठीक है. तो V naught on Vi इसमें क्या करना है? How do you do that? What's the answer? What is the output voltage across a resistor? क्या आउटपुट है? You will not be sorry, believe me. Across a resistor, I want that output power. That should be all right, yeah? IC into, what is IC? So that's the current. उसके बाद multiplied by RC. उसके बाद क्या है वो इनपुट? क्या इनपुट पावर है? ओह सॉरी सॉरी, थोड़ा अपन उसको अलग से लिखते हैं. आई एम सॉरी. V out is this, and हाँ थोड़ा सा V out is this. थोड़ा सा I have to make an assumption, but can we get away without making an assumption? That's the whole story. Okay, let us run with this. What is okay, what is IC? Correct. Do we know can we get the value for IC? That's the point I want to convey. How do you know IC? नहीं IC इसमें सामने में कैसे मैथमेटिक्स? क्या अपना मेन जो नोबेल प्राइज विनिंग आइडिया था वो क्या था? मेरी थ्योरी है कि जिसने एक बार बीटा कहा वो ट्रांजिस्टर कभी समझ नहीं सकता. एंड वेरी गुड. ये बीटा का मैं आपको स्टोरी बाद में करता हूं. बीटा जिसने कह दिया वो ट्रांजिस्टर पे सीख नहीं सकता. Because that's how it is taught, right? So what do we say about, there are two types of transistors, right? BJT and FETs, right? What's the difference between the two? I mean, property wise. What is BJT? What is, there is a popular notion. So, this is known as current amplifier and this is known as voltage amplifier. ठीक है? You heard of that? Maybe you don't agree, but अब जिसने ये किया वो गया, वो इलेक्ट्रॉनिक्स में उसका काम नहीं जिंदगी में. जिसने ये किया वो गया. Because you can do UPSC exam, but you cannot do real electronics. Gaya. The reason both are called transistors, is because they are both voltage amplifiers. आपने बीटा किया तो आप गए. If you say, the reason I say is this, because beta varies so much. Unless your design is independent of beta, that design will never work. अगर आपने डिजाइन में कहीं भी बीटा का काम लिया है तो आपकी डिजाइन काम नहीं करेगी. You have to design and then check that for this range of beta my design works or not. You cannot have beta as a part of your design process. Only beta is a check that whether my design will work or not. Okay, so now क्या अपना नोबेल प्राइज विनिंग आइडिया ये था कि इट डज नॉट डिपेंड ऑन दिस करंट, राइट? वो था. और वो करंट का मैग्नीट्यूड अपन ने कुछ कहा था. We had the electrons flowing. What did we say about electrons flowing from here to there? अपन ने कहा था यहां इलेक्ट्रॉन जा रहा है और यहां भी इलेक्ट्रॉन जा रहे हैं. तो what did we say about that? The number of electrons going there, did any electron go there? Yes. Very few. So we say ignore. So जो ये इलेक्ट्रॉन जा रहे थे वो ये यहां जा रहे हैं. So that is a Nobel Prize winning idea. So जो ये current है, how do you get that current? What is the relation between this current and that current? So what is this equal to? IBE. एक मिनट. This is equal to IBE times RC, right? तो मैं गलत कह रहा हूं? Both are the same because no current is going to the base, right? Same story. So what is expression of IB? This I'll give you for free. There's a diode equation, you remember, maybe you forgot, that's all right, that's no, but it is exponential, right? That's a diode equation. The current through the diode is this. Yeah? ये तो देखा होगा कभी? Yes, no? नहीं? अब ये देखा. So now, what is this? So we can do it this way. IS 1 plus VI VT plus BI square No harm done? राइट इसको थोड़ा सा नेग्लेक्टिंग हायर ऑर्डर टर्म्स वगैरह ये सब वो तो यूपीएससी का मामला है हायर ऑर्डर टर्म्स नेग्लेक्ट एंड ऑल दैट नाउ मैंने कोई गड़बड़ करी क्या दिस इज राइट दिस इज राइट I don't think anything is wrong here. E to the power. Can somebody check? I'm sure that it is diode equation. कोई check करके बताएं Google से. नहीं नहीं. माइनस कहाँ माइनस है? Yeah. That's what I think I made a mistake. Okay. So ये है मेरे ख्याल से. So if this is the current becomes I1 minus I. No. Where is I? No, IS I think is all right. That's right. ये हुई ना बात यार -1 हाँ because that's the minus saturation current here that is minus that's why it is -1 हाँ और C equals to S This is right. Okay. Yes. Okay. So sorry, it is. But there is nothing much there. I think this one does not matter. I just goofed up a little bit. This one is there, no harm done. But this number is much larger than one in forward bias. So we don't worry about that. So we break the input to VI0 and delta VI, the change. So VI we can take out like that. That's the exponential part. We do it with higher order terms. We just take out. So this is the final answer you get. So IC0 is the bias current. I didn't want to get into that, but there is no option. So that is the current due to the voltage VI0. So this voltage is VI0 plus delta VI. This voltage is Vout is Vout0 plus delta Vout. Okay. So I'm changing change in the output voltage due to the change in the input voltage. And that's the expression I get, sorry, VI. That's the expression I get. Now, how do you get a gain of million using this formula? If you want to increase the gain, what do you do? So VT is fixed, that's a parameter of the temperature and all that sort of stuff. IC0 is fixed because there is the bias one, you can set it, but let's say it is fixed. So if I want to get huge gain, what do I do? That's a gain of 10,000. Yes? Kaise sir? Gain of 10,000 if I want to have, what do I, the parameters you can select these parameters of the amplifier. So which parameter I have to select appropriately if I want a gain of 10,000? Or if I want a large gain, which is the parameter I need to get large? Right? कौन सा पैरामीटर है जो आई कैन मेक लार्ज एंड मेक द गेन लार्ज? क्या कौन सा चॉइस कर सकता हूं? ये मेरे आई एम अ डिजाइनर ऑफ दिस एम्पलीफायर. विच पैरामीटर कैन आई पिक एंड मेक गेन लार्ज? ये सर क्या है? कितनी चीजें हैं वहां? 3 चीजें हैं, राइट? IC 0 मैं कह रहा हूं फिक्स्ड है, VT फिक्स्ड है, तो क्या हम बदल सकते हैं? RC. I can choose RC to be 10,000, 100,000. I can easily choose this to be 100,000. The whole idea is that this side of the circuit does not matter what current is flowing, it will be exactly the same as that current. And that current can be changed by a large amount by tiny change in the forward bias. And that large change, I am running it through the collector current, collector resistance RC to give me enormous voltage gains. Okay, so this is normally IC is 1 milliamp, VT is 26. So if I got a gain of this resistor here, I got a gain of 4,000. And I can make much higher resistances. वो तो थोड़ा electronics की बात है. There are active resistors which are transistors used as resistors. So it's available cheap. I mean you can have 1 million transistors in a chip. So you can use that and you can have very large resistances there. The only thing is that the constraint is it should not be, this should not be larger than that, etc., etc. So you just want high gain, you don't do that. So this is how the whole setup works. And this is because of the principle of diffusion. Then whatever the current, small voltage, this is forward bias. So by very small change in this voltage, I can affect large changes in this current. And those large changes show up across RC. And when they show up across RC, they generate huge voltage, depending on the value of RC. And because of that, you can get, if you put 2 or 3 together, suppose I got a 400, 2 of them together is 16 times 10 to the power 6, 16 million. Right? 4,000, 2 of them you put together, you got a huge gain. Just 2 amplifiers. Nothing much. Right? तो अगर आप ऑप एम्प देख के आपको डर लगता, पसीने छूट जाएंगे, राइट? मैं आपको ऑप एम्प दे दूँ, इसको एनालाइज करो, सबके पसीने छूट जाएंगे. But it is not anything much. You have to just look at these things, identify different parts, and you are done. Okay, so although this is not directly related, but I thought that we would do this photovoltaic cells, and this about this very large amplification is related to that. And as an electrical engineer, I think you should be familiar, or you should have a good understanding of how we get such large gains. And without large gains, you would not be able to get the benefits of feedback, etc., etc. Okay, so FET devices, how do you get large gains? What do you do in FET devices? What is the principle in FET devices that to attain gain? You all use FET devices as switches, right? Switching devices use. But that also based on what? Gain. Because you put in some voltage and the current is so high that it will switch on. If you take away the bias voltage, it will switch off, right? And etc., etc. So there you change the width of the channel. By changing the voltage, change the width of the channel and gain, etc., etc. But BJT has got very high gains. So although MOSFETs are very good in many ways because they are easy to fabricate, I don't know that much about fabrication, but they are easy to fabricate and all that. So MOSFETs are very popular, but still when you need high gain, you need this thing. Okay? So now I thought I'll complete. I was not happy the way I left there because although we had all the technically right material there, we had everything right, but this tells you clearly how it works as an amplifier. Sorry, this is what I wanted to convey. It works as an amplifier. The extra power you need, this guy is not supplying any power, very little power, because Vi is small, right? But the entire power comes from this source here. So you've got a battery connected. So the power does not come from the input, it comes from a buffer. That is the most important point about transistor operation. That the output power comes from the buffer, not from the input. Transformer में कहाँ से आती है output power? When you got a transformer, the output power comes from input power. V primary, I primary is a V secondary, I secondary. Okay? So you are not introducing any power, you are just changing the voltage levels. But here, you change voltage levels and inject huge amount of power. Okay, so that is the basic principle. I think still, TV transmission and all that, most of it is still based on tubes. Because the amount of power you have to transmit does not come well with the transistor, it's still the tubes. Okay. So, ye mera, and still I have got two more dot points to go, but let's move on. Kaise? We can go to the slides? पर ध्यान दिखना चाहिए ना. Okay. Yeah. So अब थोड़ा सा I think I need help from you. जैसे उसको अंग्रेजी में कहते हैं switching gears. We are switching gears now. Machine learning. Why do we think, what can we do if I've got a lot of data? What can I do with the data? I mean, I need serious feedback from you. आप लोग काफी लोग research कर रहे हो. I heard machine learning, research this, optimization that. So what is it I can do? Suppose I've got data from all the customers, their load consumption, temperature, this, that. What can I do with that data? Honestly, I am not 100% sure what I can do with the data. अच्छा बताएं आपको लगेगा फंस गई, पर आप फंस गए. डेटा एनालिसिस करके क्या करेंगे आप? What are you going to find out? Of what? प्रॉब्लम बताएं मेरे को. Predict, okay? Very good. Predict. क्या predict करना है? मतलब this is serious. मैं दूसरा तो आपको इधर गोल गोल घुमा रहा था because I knew the answer. या मेरे को आंसर नहीं मालूम. तो जो आप कहोगे वही I have to accept and we can discuss on that.
Based on previous data, we can predict how much demand and load can increase.
Okay, predict load increase. Good. What else can we predict? Very good. So आपको वो बताना पड़ेगा. Customer requirement pattern. कहाँ गए वो? जो डेटा लाने वाले थे, आप, not you. रवि साहब भाग गए. ओके, सर कस्टमर रिक्वायरमेंट पैटर्न इज गुड. तो व्हाट डू आई नो, ये तो इसमें तो मतलब आपने जो चीज कही उसमें मेरे को तो कुछ समझ आया नहीं क्या है. आपको स्पेसिफिक चीजें बोलनी पड़ेंगी. क्या व्हाट इज इट यू वांट टू नो? हाँ, पर क्या उसको तो पिक्चर देखनी है, उसको सलमान खान से मिलना है. आपको यू टू बी स्पेसिफिक ना. मैडम को करने दो अपने, फिर मैं आपको छोड़ूंगा नहीं. हम मैडम बोल रहे हैं तो मैडम से लेट्स अस फिनिश दैट. तो व्हाट डू यू मीन बाय कस्टमर रिक्वायरमेंट? वो तो आपने कर दिया ऊपर, लोड फोरकास्टिंग. कस्टमर रिक्वायरमेंट से व्हाट डू यू? हाँ, ओके, कस्टमर को वेरी गुड. cheaper electricity cost, right? Have I said it properly? Okay, एक requirement. और
सर अवेलेबिलिटी 24 आवर्स, हर किसी लोड शेडिंग किसी को नहीं चाहिए. ये लोड शेडिंग ना हो हर कोई चाहता है ना, तो दैट विल बी कस्टमर बिगेस्ट रिक्वायरमेंट.
राइट, ये दो लोड शेडिंग में आ गया ना मैम. ऐसा क्या कर रहे हैं आप? हैं? और बोले क्वालिटी. वेरी गुड. पावर क्वालिटी, राइट. हार्मोनिक्स नहीं, वोल्टेज लेवल फ्लक्चुएट नहीं कर रहा, एक्सेट्रा एक्सेट्रा. एनीथिंग एल्स? T&D losses. Yeah, it's a new thing, right? New item.
It is increasing year on year.
नहीं, वो न्यू आइटम है ना, वो मतलब जो न्यू आइटम. या if I say anything else for customer requirement? Yes sir, आप बताएं. Predict load. What else?
ARR. Predict ARR.
Predict load. What else? ये दुनिया इस तरह पागल है इसके पीछे, तो there must be something they get out of it, right? Because I don't know how many people are involved in doing data processing for that, data analysis and data analytics. पर मेरे को ये पता नहीं कि वो कर क्या रहे हैं. मेरे खुद के स्टूडेंट्स हैं, वो मेरे को इतना झांसा देते हैं कि सर वी आर डूइंग दैट. मेरे को ही समझ नहीं आता.
This analysis is very good for publishing.
ये सब बताएं.
ट्रांसपेरेंसी, कस्टमर और जो मेन सप्लायर उसके बीच में ट्रांसपेरेंसी, जैसे बिलिंग सिस्टम जो हमारा रहता है उसमें ट्रांसपेरेंसी हो
क्यों?
कि इतना चार्ज क्यों किया. ट्रांसपेरेंसी.
Right? That's good point, very good point. Okay, they have to detail कि why the bill is the way it is, right? Very good.
In prediction you can add ARR also.
Prediction कौन सा?
Prediction number 1.
Yeah.
You can add ARR also. Annual revenue requirement.
Okay. So yeah, good. Predict load increase, annual.
You can predict FAC also.
What is FSC? आप ये सब नहीं.
Adjustment surcharge.
या सरचार्ज तो एस होता है कि नहीं? चार्ज. ओके.
And then you can cross subsidy also you can predict.
क्रॉस सब्सिडी.
If you talk of prediction, lot of predictions are expected.
Okay. So that's all right. Fine. Anything else machine can do? Pardon? तो ये तो हम पहले भी कर ही रहे थे. what are the things we can do with machine learning which we were unable to do before? And how can we do it better with machine learning?
With machine learning, I think it will be reliable. Now it is everything is adjusted. And if it is manual, then reports are manipulated.
Okay.
Whatever political parties want, that report is public, everything is scrapped.
Okay.
That's the fact of life.
Okay.
There can be missing data also.
Missing data. It can account for missing data. Can you pick up one thing we can focus now? इनमें से इतना लिखा है आपने तो. Then transparency. Okay, I am happy to learn with anything you want. Transparency in tariff. You want to run with that?
No, anything. I mean, the moment a customer logs into a particular account, I mean, website, he should have transparency for everything. Then entire website is solved automatically.
So transparency means what information you want on the website.
The expected load shedding schedule, power quality analytics, the D&D losses, recovery charts, annual revenue requirement, division-wise, subdivision-wise, cross-subsidy calculations, load management, generation and load matching data.
Correct. But how is machine learning going to help you? Okay, put the question other way. You want transparency? अभी मेरे को लिखना नहीं आता स्पेलिंग, डोंट कोट मी ऑन दैट बिकॉज मैं एकदम ही स्पेलिंग गई मेरी, आई एम वर्स देन प्राइमरी स्कूल बिकॉज वो ऑटो करेक्शन होता है, इसलिए आई रियली आई एम गॉन. ओके, एनीवे, सो ट्रांसपेरेंसी आपको करना है तो व्हाट डेटा डू यू नीड?
मेन डेटा जो आप बोल रहे थे उसी से मिक्सर का निकाल के ये सब
स्मार्ट मीटर डेटा.
any data, sir. Data will be multiple sources of data. It could be code sourcing data, it could be load management data, it could be generation data.
So it's-
Integration of all that.
So I got generation data, I got smart meter data. What else data you need?
Coal prices, coal fuel availability.
Availability from all the sources, maybe thermal, hydro, whatever, all the sources. सिर्फ कोल ही नहीं आएगा ना source.
Cost, okay. Generation cost.
Fuel cost for all generation.
Generation cost, right? जो भी cost है.
फिर ये करने जाएंगे ना तो 15 दिन भी कम पड़ेंगे. Let us focus only on the smart grid. So when you have a smart grid, what advantages one can expect it?
Exactly, that's what I was coming to.
So if you limit that question to that particular, I mean, if you funnel down,
So smart grid का smart in what way? That's what I'm trying to get first. I'm trying to be precise so that we can formulate a mathematical problem. That's what I'm trying to do. How to look at it mathematically speaking, not in general terms. So what is it? What methods do we need? How to match these various algorithms to our problem? So what you said is very right, smart grids. But in smart grids, what are we trying to be smart about?
sir, one is load management.
Okay.
Demand management. Second will be definitely revenue side will be part of the smart grid. The recovery and T&D losses. Then it will be helpful for planning. It will automatically give reports about power quality.
Yeah, आपकी बात मैं समझ रहा हूँ, but so what is the data we have? We first list the data. We specify mathematically some problem, as you say, rightly said, we have to identify one problem or two problems. So data available is smart meters, generation cost, so ये निकाल देते हैं अभी.
अभी
अभी ये निकाल देते हैं. तो डेटा, दिस डेटा इज अवेलेबल, वॉट एवर इज अवेलेबल टू अस. ओके, स्मार्ट मीटर्स, जनरेशन
जनरेशन क्लॉज में नहीं आएगा सर. सिर्फ स्मार्ट डेटा, ग्रिड डेटा विल बी अवेलेबल एंड at max generation data can be made available.
ओके, जनरेशन डेटा, गुड. जनरेशन डेटा, स्मार्ट मीटर्स, दैट इज द लोड डेटा अवेलेबल. अब इसमें
Load will translate automatic load data and also collection efficiency will be and losses will be transferred automatically.
yeah, that's right. So if you got smart meter data, you got all the voltages and currents and all. Let's assume that we got voltages and currents for each consumer, right? With this data, what do you want to do now?
With this data, as I said, we can answer some of the left side
हाँ, तो कौन सा एक मेरे को आइडेंटिफाई करो.
3 number T&D losses.
या टी लॉसेस, तो उसके लिए वो तो लोड फ्लो चल जाएगा ना.
हाँ, पब्लिक को समझते नहीं, जो डिक्लेयर करते हैं वो
अरे यार, पब्लिक की आप जोड़ो, मेरे को इलेक्शन ही लड़ना भी. I am going scientifically putting out the right T&D loss. वो अपन उसकी चिंता करें.
नहीं, but if it is transparent, naturally it is open to public.
या चलो पब्लिक को ओपन है, नहीं है, we don't worry, but we can calculate T&D losses using the smart meter data, node voltage and node voltages. Once we have, we can calculate the losses, right? तो उससे मशीन लर्निंग की क्या जरूरत है? What does machine learning do there? See, there are many problems in power systems. It has been running for over 100 years now. But what are the specific problems we can address using machine learning? That's what we want to.
Then we can only talk of grid stability, source versus demand matching.
Okay, yeah, आप मैडम क्या कह रहे थे?
सर स्मार्ट मीटर्स जो है इंस्टेंट सॉल्यूशन भी बोल सकते
तो किस चीज का?
We can find out at what small areas require more energy, less energy, because we have generation data and smart meters. Smart meters will give us idea which areas require at what time high energy time, predict all that things. Cluster wise also, so that we can develop smartly.
So smart meters, तो स्मार्ट मीटर क्या देंगे बताएं आप?
थोड़ा बोलने दीजिए.
So I'm just trying to, okay. So let's say, can I say that load demand from smart meters? Load demand में आपको क्या चाहिए? You had some points there. So what can you do about load demand? So you wanted load demand? आप क्या कह रहे थे?
Sir, I am saying in some areas, suppose it requires sometimes more energy, less energy, we can help out smart meters, we can find out clusters and user availability. Which time which requires.
So पहला, the first thing is you region wise you can have load forecast. इस पहला ये आपकी point है. Region wise we can have load forecast, right? What दूसरा point?
We can we have with both data, generation and smart meters. So we have also known the losses by calculations. So we can predict which areas have more theft also.
यार वो तो अपनी अलग, एक थोड़ा कम रखो यार, वो तो दूसरा थेफ्ट का अलग कहानी हो गया. What else? मतलब उसमें मशीन लर्निंग तो नहीं चाहिए ना, आप जस्ट ऐड कर लो जनरेशन, वो कर लो, हो गया काम आपका.
Then if you have region wise, then you can have time slot wise data.
Oh, that's right. So we can have, so load demand region wise. So load demand so let us go a little bit. So I have got 24-hour smart meter data. Right? Mathematically speaking, what is it you want? आपका जो वो problem है, so you want to know Is that what your thing boils down to? Divide consumers into groups. Right? ये आपका थोड़ा कैसे करेंगे ये स्मार्ट मीटर डेटा से? So this is a definite problem. And what do you do? I mean, I divided consumers into groups, and then what can I do with that? Pardon? हाँ बोले?
We can properly design our energy trading from generation side to there.
So what you are saying is for different consumers I have different prices.
सर एलटी
Based on industrial area,
हाँ,
there more energy is required, and they are
वो तो पहले से ही पता है ना मेरे भाई. मशीन लर्निंग की बात करो कि I have got 24-hour data now, all consumers. What can I do in the next 24 hours or next 2 hours or next 4 hours where I can use machine learning tools? आपने कहा divide them into groups. That's perfectly all right. What do I do with those groups? आपने कंज्यूमर लिए नागपुर के 10 ग्रुप में डिवाइड कर दिया, अब उनसे करें क्या? सर्टिफिकेट दें आप ग्रुप 1 में ग्रुप 2 मतलब they won't like it.
उनका कंजम्पशन पैटर्न देखेंगे क्या करें?
actually my thinking is like that. If we divide into group, we see consumption pattern, and then we decide our distribution side how to distribute so that load shedding will be less and
So, see, this is a very important point. What you use. Suppose I divide them into groups, and I see some pattern, and it has to. I think we can link it to the losses. So we have got to schedule many generators, right? Batteries. There are many resources we need to schedule for the next day, and the way we can do it based on this data, we can do it so that those resources are used optimally. In the sense we get battery usage, maximum battery usage, battery charging, battery discharging, transmission losses, distribution losses. वो एक problem. Does it seem reasonable problem? That we have smart data, we use it to schedule our generation or whatever schedulable devices are there. The rooftop है उसको तो मैं कुछ कर नहीं सकता, it will keep on going. But if you have got a battery, if you have got a hydro system, if you have got any other system, then you can do it. And why is machine learning important there? ठीक है, problem set हो गया सबका? I think roughly we are all right. It is something new for me also. So that all those points are good. I am not. So we have converged to that. So what data do we need, or what data do we think will be useful? और क्या क्या डेटा हमको चाहिए which can be useful in our this we have set a target for ourselves that we'll take this 24-hour data, we have got so many generators here, we will schedule them for next 24 hours based on that. So what data do we want? We have our aim clear that we have got X numbers of generators, and we want to schedule them so that we minimize our losses, minimize this, minimize that, etc., etc., etc. तो उसके लिए fun pause. So उसके लिए, see, there are two parts to this what we are discussing. One is what you will do with the data, and secondly, or firstly, is how you analyze the data, and for our problem that we have at hand, we want to classify or cluster the consumers. Am I getting that right? We want to cluster the consumers, and then once we have got the clusters, we will go to the next step, how to manage that. So, what else do we need? When we are talking about machine learning, we might, or if there are features that don't have a good mathematical representation, and if those features are important in our decision, that's where, in my mind, machine learning is helpful. Right? If the people, we somehow they have got a features. So you can have 4 income. I'm just putting down, say, इसमें maybe I'm as new as you are, or you might be, sorry, wrong to say that, but I am certainly not more experienced than you are. That is for sure. You can be more experienced than I am. So this is what I'm jotting down some things there. Yeah?
Sorry to differ, but all these other than 1 and 2, 3 onwards is not available from grid data.
Good, very good point.
So we are focusing our attention only on grid, smart grid and grid data only. Even power factor will not be available. Power factor is specific to a given consumer. The
Yes.
grid will never will have any power factor.
Correct? Okay. So that's a very, this is where we are coming into the machine learning. Where you said,
Power factor grid will have power factor.
स्मार्ट मीटर में तो होता है ना,
Power factor is a feature of that particular consumer.
कंज्यूमर का ही फीचर. So this is data for each consumer. This is data for each consumer.
Are we talking about the local grid in the distribution network, or we are talking of a pure state grid?
Let's talk about distribution system.
Then there is no question of generator. There is only one feeder. Then instead of generator, you talk of feeder.
ऐसी बात नहीं है सर, आजकल बहुत जनरेशन डिस्ट्रीब्यूशन सिस्टम में जनरेटर्स हैं, बैटरीज हैं.
Rooftop are classified as prosumers. So they consume and
Correct, but there are batteries have to be installed.
batteries are not feeding back to grid. They are all
नहीं, बैटरीज फीड करती हैं.
EV are not feeding back to grid.
वो बैटरीज तो करते हैं ना, आजकल काफी कम्युनल बैटरीज आ गई हैं. People, their communities, they get together and buy batteries.
Sir, sorry, but in Maharashtra, I have never seen a single battery installation which is feeding to grid. It will come. If there is one, I would like to visit.
No.
It may come. That's a
जैसे बढ़ेगा ईवी कैसे होगा?
No, I am sorry, it is not a practicable solution that battery feeding back to grid is out of grid.
आपकी बात सही है, पर हम जो गुजरात से आते हैं उनको लगता है कि महाराष्ट्र के बाहर भी दुनिया है. आपको लगता है कि दुनिया का अंत महाराष्ट्र से है, पर उसके आगे भी दुनिया है. Just a joke, but there are all these large generations have entered, at least in Australia, they have entered distribution system, reasonably large generation.
We are also trying to get.
Yeah. So how to schedule them, how to schedule batteries and all, they are potentially significant problems because you want to maximize your profit because your battery का expense बहुत होता है. So I take it that this data is available from individual consumers. Let's assume that, right? उसमें कोई, there's not a big assumption.
If it is consumer, then all 7 is available.
So all seven तो normally नहीं होगा. कौन आपको income बताएगा, कौन number of family members बताएगा, नहीं बताएगा ना. You can't get the data. So machine learning is helpful in getting the data. Right? But मैं अभी इतना, I am not so experienced, but there are lot of research papers. So we are discussing about new things, innovative things, what type of research people are doing. So these are valid areas of research that you take the known data and generate the data which is so weird that you cannot do it with any mathematical calculation. That's what I'm trying to convey. कि अगर मैथमेटिकल जैसे लोड फोरकास्टिंग है तो लोड फोरकास्टिंग मेनी टाइम्स यू कैन डू वेरी वेल विद टाइम सीरीज डेटा. So if you want to use machine learning, there has to be a reason for that. Because machine learning takes hours and hours to train, and then once it is trained, very few people know how it is trained. So if you have a definite algorithm, mathematical algorithm, whose properties are known, you are better off using that mathematical algorithm. Right? So that's what I'm trying to distinguish. कि कौन सी ऐसी चीज है which cannot be captured by maths and which is helpful. दो चीजें होनी चाहिए. That's how I'm thinking. मैं आपको ये मैंने जो एम्पलीफायर का कागज मतलब सीना ठोक के कह सकता था. Right. Here I don't know. I'm just discussing. I'm putting the ideas to you. In the last 1 month, I've been thinking these things through myself, reading research papers, etc., etc. But I can say with some confidence that all these things are in a state of flux. कोई ऐसी चीज नहीं है which is laid down in concrete now कि ऐसा ऐसा होता है. People are thinking, people are suggesting, and all these things are happening. So there are.
Again, for training, sir, conventional methods are used. Without that, how they
Conventional method means?
this time series of जो आपने बोला.
Yeah, वो तो forecast वगैरह के लिए yes, but to get to number of family members. ये तो it is.
सर्वे के थ्रू हो जाएगा.
Ah, very good. So survey लोग बाग देंगे नहीं देंगे, that's the question. If you can take the survey, then yes. But why people will give that information to you?
जैसे वो रेशन कार्ड पे वो रहता ही है.
Appliances भी आप मुझे
आधार कहीं से मिल जाएगा.
कहाँ से? वो घर में ज़्यादा है बताएंगे क्यों? मतलब ज़्यादा इलेक्ट्रॉनिक चीज़ें हैं वो बताएंगे क्यों? डाटा देंगे क्यों?
That's what I'm saying, that these things people in general, Aadhaar card hai, but Aadhaar card there are big rules who can access that data. I mean, power company cannot access Aadhaar data. So there are huge restrictions on what data you can obtain, power companies can obtain.
If we train with the reliable data first, machine learning, if we train with reliable data, it can be used for taking other data.
Correct. So
We can use it data for power consumption, voltage, power factor to get the income of the people. The income tax department can use that data whether they have really filed the proper ITR or not.
नहीं वो क्रॉस का नहीं चलेगा. लेट्स नॉट टॉक अबाउट क्रॉस डिपार्टमेंटल शेयरिंग ऑफ डेटा. वो नहीं चलेगा क्योंकि
Electricity bill.
electricity, so whatever electricity bill, whatever electricity,
What it shows.
that's all you can have.
Data set उसी से बने.
So how would number of family members be decided? Let's see how I can decide about महाराष्ट्र का. मैं नहीं कह रहा, पर जो दुनिया महाराष्ट्र के बाहर है. Oh yeah, oh sorry sir, मैंने महाराष्ट्र कुछ कहा और मेरी नहीं, मैं मराठी लोगों से बहुत डरता हूँ. So not here you have to think of something different, but similar जैसे western countries में है, right? How would you decide the number of people living in the house? And यार सीओटी कंजम्पशन कहाँ से लाओगे आप? कहाँ से लाओगे? घर पे सीओटी मीटर है क्या? हाँ हाँ.
ये अपना प्रॉब्लम ये है कि एक फैमिली में कितने मेंबर्स हैं. अपना प्रॉब्लम ये है कि पर्टिकुलर एरिया में कंजम्पशन कितना हो.
Yeah, that's right. So that we know from that. एक फैमिली में कितने मेंबर हैं ये थोड़ा इंपॉर्टेंट है.
तो अपने को इलेक्शन तो लड़ना नहीं है.
एक फैमिली में मेंबर कितने हैं, that might depend on the usage pattern is related to. Yeah. So
बट जो ट्रांसफार्मर एक होता है,
हाँ,
अगर एक ट्रांसफार्मर एरिया जो है 100 kVA का,
यस,
तो नियर अबाउट 50 to 60 कंज्यूमर वहाँ पे हम लोग कनेक्ट कर सकते
करेक्ट.
हैं, और वहाँ पे ट्रांसफार्मर में डीटीसी मीटर होता है.
व्हाट इज डीटीसी, क्या है वो?
डिस्ट्रीब्यूशन ट्रांसफॉर्मर.
जैसे अपने यहाँ पे एनर्जी मीटर होता है,
हाँ
तो वहाँ पे डीटीसी मीटर, डीटीसी कहा जाता है.
हाँ ठीक. Yeah.
तो बत्ती अगर वहाँ की आप रीडिंग लिया जाए 30 डेज की, तो कितना कंजम्पशन है वो निकाल सकते हैं.
Yeah, you are very right. So upon we are give also, can we do anything finer? आपकी बात 100% सही है कि at the feeder level I got information available. But in the finer, जैसे feeder है अभी जैसे सर ने कहा कि feeder के अंदर कोई महाराष्ट्र में जनरेशन नहीं है, but there are many places where feeder के इस साइड जनरेशन है, राइट? बैटरी है, ये है, वो है, तो हाउ टू शेड्यूल दैट?
एक सबस्टेशन मान लिया जाए 33/11 kV का सबस्टेशन,
यस,
ठीक है, और एक सबस्टेशन से मिनिमम 3 फीडर्स होते हैं,
करेक्ट,
और हर एक फीडर पे एक मीटरिंग होता है,
करेक्ट, यस,
और उसी पे वो लॉसेस चलता है.
यस,
जैसे
एग्रीड,
दो टाइप के लॉसेस है, एक टीएनडी लॉस वो तो है,
यस,
एंड सेकंड इज कमर्शियल लॉस,
यस,
रिलेटेड टू टैरिफ.
यस,
ये दो लॉसेस हैं
यस,
टेक्निकली, और वो हिसाब से सब वो सिस्टम चलता है, और मैनिपुलेशन भी होता है.
correct. That's 100% right. But we want to do something more. What is more we want to do? आपके अंदर जो है, जो फीडर का एरिया है, वहाँ अगर ईवीज हैं, वहाँ अगर बैटरीज हैं, वहाँ अगर विंड है, सोलर है, तो हाउ टू शेड्यूल इट so that you can minimize the losses inside your system, distribution area.
सर कन्वेंशनल नॉन कन्वेंशनल ये दो सोर्स हैं.
हाँ,
तो अभी जो है, अभी ग्रिड सिस्टम हो रहा है अपना, बराबर. नॉन कन्वेंशनल जो है मैक्सिमम अभी जो सोलर रूफटॉप जो चल रहा है, तो रिमोट एरियाज में क्या हो रहा है, जैसे दो फीडर्स होते हैं, एक ऑफलाइन चलता है, ठीक है, और एक एजी फीडर चलता है, तो टोटली उसको अभी डिवाइड कर रहे हैं.
yes,
तो जो सोलर है, क्योंकि सोलर नेचुरली मॉर्निंग आवर्स में रहता है, दिन भर चलता है, तो 11 to 12 आवर्स सोलर पे चलेगा एजी फीडर, तो वो सेपरेशन ऑफलाइन सेपरेशन और वैसे सेपरेशन
correct.
फिलहाल तो वो शुरू है.
Yeah, no, that's right. I agree that these are the trends, these are the current practices. It's very important to know the practices. I can't deny that.
एंड सर जो स्मार्ट मीटरिंग जो हो रहा है,
हाँ.
उसका उतना यूजेज यानी उसका उतना बेनिफिट नहीं दिख
अरे आपके तो आप एम्प्लॉयड है ना?
रहा है. फिलहाल में नहीं दिख रहा है.
नहीं, आप एम्प्लॉयड है ना एज एन इंजीनियर, है ना? हमको ये नए लोगों के लिए नौकरी ढूंढनी है.
पीएचडी के बाद क्या करेगा?
हमको इनके लिए नौकरी ढूंढनी है कि उनको करने को कुछ देना है. You understand? So smart grid, people 15 साल पहले भी people who were very much involved in the power industry, they pushed for smart grid mainly because of employment reasons. आप कह रहे हैं सही, एजी फीडर चलता है, वो चलता रहेगा, पर लोगों को नौकरी देना is also a very important part of the society. You have to provide employment. Or these type of employments are very good because they provide at a higher level, white collar worker. Right? They earn more, they spend more, they pay more taxes, हजार चीजें हैं. Right? So आप जो कह रहे हैं, and most of the people in power industry will say that अरे चल रहा है, किसमें क्या है, चलता रहेगा, ऐसे ही चलता रहेगा. But that may be well be true. 1000% में मानता हूँ कि ऐसे चलता रहेगा, it might not be wrong. But लोगों को बदलना है. अब उसको खुजली हुई है तो क्या करोगे? You have to satisfy the itch. और उसमें कुछ फायदा भी हो सकता है. I mean, if you get rid of the coal, it's quite a lot of benefit. So, I mean, we have to look at many different aspects when we are considering that. Matlab, here we are educational institute, so we have to look at research, we have to look not only current practices, we have to know current practices, but we may not have to stick to current practices. आपकी बात सही है, it's very important to know what are the current practices, what are the regulations, what is the regulating authority, all that, but that may be also changed. There may be around, I don't know how long ago that people could not sell electricity. Now in Australia and all, you can have communal electricity battery and then you can sell it to the system. You can charge it with all rooftop PVs.
सोलर के सोलर से करते ही है ना जिनके यहाँ पे
हाँ, yeah.
वो बेच सकते हैं ना सर
हाँ, that's right. So all those are there. So बेच सकते हैं grid को or to charge your battery. Which one would we want? That's what we want to work out. I have got rooftop solar. हम सब इकट्ठे हो गए. हमने कहा यार ये इलेक्ट्रिसिटी कंपनी लूटती है. Instead of that, we have buy our own battery. People have done that. They have bought their own batteries. Community level. And they charge that battery through their rooftop solar rather than sell it to the electricity grid. And then use it when the prices are high. So ये आसान है मतलब how should I say? In saying that, it is hard to realize the mathematical complexity of this problem. आप समझ रहे हैं? ये मैंने बहुत छोटी बात जो कही है, even I don't know how complex mathematically is this problem. I mean, let's look at the problem. I have got rooftop solar, 50 लोगों के पास हैं. They want to decide whether to sell it to the grid or charge a battery.
Multi-objective.
हाँ तो वो कितना difficult problem है, I really do not know. But the tools people use, they are so massive that either all of them are crazy. क्यों वो काम लेते हैं? Why do they use? So it's very hard to get out of people why they are using these complicated tools. Is that not a simple solution to these problems? But we are here to identify the problems, and what I can say from the literature, all these things are very important to do this. I mean, one of the appliances, यहाँ तो आपका experience नहीं होगा, पर in Western countries, what is the appliance which dominates the load? Can you guess? घर पे है किसी के? AC और EV? Heater. Dryer is the biggest one. जो नहीं वो closed dryer. वो 3 किलोवाट का होता है. घंटे 1.5 घंटे चलता है, 2 घंटे चलता है. So typically in a Western country, house load is considered to be 6 kilowatt roughly. उसकी 6 किलोवाट के हिसाब से प्लानिंग होती है. उसमें 3 किलोवाट तो ड्रायर ही खा जाता है. So what I'm trying to say is, and what you said, EV and heating and all that is perfectly all right. So it pays them somehow to identify which houses use these things more. So if they have that data, it seems that's very helpful. कि उसके पास कितने devices, कितने अलग-अलग तरह के appliances हैं. So when they have got different type of appliances, they know which appliance works when. And then for them, they can not only have a bulk load estimate, they can have a fine-grained load estimate. Based on that, they can do many, many different things. So maybe we can stop here now. So tomorrow when we start, we will start looking at the clustering problems and all that, what we have done, so that what are the methods that we can use to do these problems. Okay? So, आज तो बस इतना ही.
Food for thought.
Thank you, sir. Actually, he was very tired, but I requested him to continue the lecture because we have the another sessions to attend in the department. So thank you, sir. So we'll have tea break, and next session will be started for the simulation programming, that MATLAB simulation. So please, you first attend the lecture here and see how you can do the simulation. And if you have laptop, you can start directly doing the simulation. And otherwise you can listen it first and then you can move to the computer lab and you try it there, okay? So we'll keep that lab open for maybe 6 or 7 p.m. maybe, okay, for you, for to practice it, all the simulation that you are seeing here, okay? So please attend the next session. Thank you.
सिमुलेशन डेटा देने वाले आप है ना मशीन लर्निंग अप्लाई करने के लिए डेटा आपके पास है हाँ ये सर ओ आए ओके कौन करे वो कैसे करे
भागने की सोच रहा था
ఎట్లా పని చేస్తుంది చెప్పమా అట్లా చేస్తారు
स्ट्रीमिंग आप
ఫస్ట్
लैब मध्ये सेशन
क्या लगे
అయిపోయింది
हाँ
గ్రూప్